graphing inequalities in two variables. So far, up until now, we've graphed inequalities in one variable. And when we've graphed one variable, we've needed one axis, just a straight number line. When we start working with two variables, I need two axes, which is when we start looking at our coordinate plane. And there are some things that are very similar to graphing inequalities in two variables as graphing inequalities in one variable, so we'll talk about that as we go along. So let's walk through the steps of how to do this. So the first thing you're going to do is take that inequality and rewrite it as an equation for now. So I've rewritten my 2y minus 4x is greater than 6. I've rewritten it as 2y minus 4x equals 6. Next, I'm going to graph the line of this equation. So there are a few ways you can do that. You can use the intercepts if you'd like. You can make a table if you'd like. That will always work. Or you can put it into slope-intercept form, which is what I've done. So I rewrote this in slope-intercept form. I came up with a y-intercept of 3 and a slope of 2, or 2 over 1. So I'm going to go to my coordinate plane. I'm going to graph my y-intercept of 3. And I'm going to use a slope of 2, or 2 over 1, to come up with some more points to show me where this line falls. So I can do a rise of 2, a run of 1, or I can do a rise of negative 2 and a run of negative 1 to show me where that line is. That's a positive line, so that makes sense that that's the way it looks. Okay, when we were working with inequalities in one variable, we graphed some points on our number line that were the boundaries of our graphs. They kind of chopped the graph into parts. The same thing's going to happen here with the line of the equation. That's going to take our coordinate plane and block it up into pieces, which we call half planes. No matter where I put that line, I have an infinite number of solutions on one side and an infinite number of solutions on the other. So we consider that the half of the coordinate plane. So I've got two half planes, one half plane on one side, the other half plane on the other side. We need to figure out how to draw this line on my equation. We're going to use a solid line if we have an equals to in our inequality, and we're going to use a dashed line if we do not have an equal sign in our inequality. So our original here just said greater than, not equal to. So I'm going to use a dashed line to represent this. So the dashed line is very similar to our number lines as that open circle. It's telling us that the solutions that are on this line do not actually make this true. So if I tried, my y-intercept is 0, 3. If I put 0, 3 in here, 6 minus 0 gives me 6. 6 is not greater than 6. So any ordered pairs on this line are not actually solutions. I can't actually use them to make my inequality true. If I did a solid line, I would do that because this was equal to. A solid line would tell me everything on that number line, that graph, that line of that equation works. And that would make sense because 6 would then equal 6. So a dashed line if we don't have equals to. All right, now we need to shade is what we're going to do. This is similar to kind of drawing our line with our arrow going in one direction or the other on the number line. We're going to shade half of this graph to show where the solutions are. And we're going to use some test points, just like we did with our number lines. So I'm going to test a point on one side of my line that I've drawn to see if it works. So origin's always a good one to use, but you can use any number on any ordered pair on here. I'm going to not use the origin. I'm going to use 1, 1 because it's friendly. So I'm going to put 1, 1 in here. And I am going to come up with negative 2 is greater than 6. Well, that's not true. That's not true. So that tells me that the point 1, 1 here is not a solution, which does tell me that points on the other side of my graph, of my line, should be a solution. I'm going to check that, though. And I just realized my math is incorrect here. I've got negative 2. I'm going to try negative 2, 2, which is up here. So I just tried 1, 1, which is over here, and that didn't work. I'm going to try negative 2, 2, which is up here, and see if that one works. And I realized I just switched my numbers around here because this is y at the front and this is the x. So I'm going to make this negative, I'm going to make that 2, make that negative 2. So this gives me a positive 4, and then this gives me a positive 8, and that gives me a positive 12. And 12 is greater than 6, which is true, and that's telling me that the kind of the left or upper side here of this graph should work. So I'm going to shade this side of the graph because these are the numbers that are going to work. So I'm just going to use you're going to use your pencil. I'm going to use my marker, and I'm just going to lightly shade the upper or left side of that graph to shade all the solutions. So any of the ordered pairs on this side are solutions to this particular inequality. The line that is graphed here is my boundary, and that line is really represented by the slope and y-intercept if I rewrite it as an equation. So very similar to our graphing inequalities in one variable, similar steps. It's just going to look a lot different on a coordinate plane. So rewrite this so you can graph the line, decide whether it's shaded or dashed, and then figure out which side to shade on.